Hi, welcome back. We're going to now continue rationalizing complex numbers using conjugates. So our objective is how do I use a complex conjugate to simplify a complex number that appears in the denominator. So when we have just an imaginary number in the denominator, we are going to multiply both the numerator and the denominator by the conjugate of the denominator. The next thing we're going to do is distribute on the numerator. We're going to use our quick method of simplifying multiplication by conjugates to simplify the denominator, and we're going to write in standard form. So I'm going to multiply both the numerator and the denominator by the conjugate of I, which is negative I. That's step one. Now I'm going to use distribution, which gives me negative I minus I squared over negative I squared, which gives me negative I minus negative 1 over negative of negative 1. So I get negative I plus 1 over 1. So I just get negative I plus 1. I'm going to do number 2 with you. We're going to multiply the numerator by positive 3i, that's the conjugate, and then the denominator by positive 3i, that's the conjugate. That gives me 39i over, this becomes 9. We just multiply those coefficients together. I'm going to reduce my fraction, and that gives me 13i over 3. That's my simplified version. Now I'm going to simplify with a full complex number in the denominator. I'm going to multiply both the numerator and the denominator by the conjugate of the denominator, and then I'm going to use distribution, and I'm going to simplify my complex conjugate on the bottom, and I'm going to write in standard form. So I'm going to multiply both the numerator by 4 plus 2i and 4 minus 2i. Sorry, 4 plus 2i and 4 plus 2i. It has to be the same on the top and the bottom. It has to be the same in both the numerator and the denominator. Okay? Otherwise you're not multiplying by 1. I'm going to distribute the top, which gives me 3 times 4 is 12. 3 times 2i is 6i. 4 times 4 is 16. 2 times 2 is 4. So I get 12 plus 6i over 20. Then I'm going to split that up into 2 pieces. It might help you to see how to reduce, and I get 12 over 20 plus 6i over 20. I'm going to reduce each of those fractions, and that's going to give me 3/5 plus 3i over 10. Right? And then we're done. This next one, we're going to multiply by the conjugate of the denominator, 1 plus 5i, and 1 plus 5i. So that's going to give me 4i plus 20i squared over 1 plus 25. I'm going to substitute in a -1 for I squared. So I get 20 times -1. I'm just moving it plus, I'm not going to do that to you. That gives me 4i plus 20 times -1 over 26. This becomes -20, so I'm going to move it to the front. -20 plus 4i over 26. And now I'm going to show you a faster way to reduce. So you could split these up if you wanted to and reduce, but look, you can pull a 4 out of well, let's just split it up. I have -20 over 26 plus 4i over 26. This first one, I'm going to divide both of them by 2, and I get -10 over 13. And then I'm going to simplify the 4 and the 26, and that gives me, I'm going to do that by 2 as well, 2i over 13. And so I end up with -10 plus 2i over 13. Either of those answers would be appropriate. -10 over 13 plus 2i over 13. That would be appropriate. Now, what we're going to do is we're going to simplify when there is both a complex numerator and a complex denominator. We're going to remember to multiply both the numerator and the denominator by the conjugate of the denominator and not the numerator. We're going to distribute in the numerator. We're going to simplify our conjugate and in the denominator. We're going to combine where we need to, and then we're going to write in standard form. So I'm going to multiply this by 4 plus 2i over 4 plus 2i. I'm going to use FOIL on the numerator, or distribution, and I get 12 plus 6i plus 20i plus 10i squared over, and now I'm going to use my shortcut, 16 plus 4. Now I'm going to take my numerator and I'm going to combine my i's, and I'm going to substitute in a -1 for I squared, and I get 12 plus 26i plus 10 times -1 over 20. Now I'm going to combine my constant terms, or my real terms, and I get 12 plus -10, so that gives me 2 plus 26i over 20. If I could figure out what causes it, I think I would stop. And now I'm going to factor a 2 out of the numerator, and that gives me 1 plus 13i. And then I'm going to cancel it with the 20 in the denominator. So I get 1 plus 13i over 10. And that's my final answer. Now sometimes it looks really hairy and you think, oh my gosh, what am I going to do with all of those complex conjugates? Here's a hint, and they do this on high stakes testing. Look to see if you have any common complex numbers on the numerator and the denominator. Look here. You have to take out the whole complex number. You can't just take out pieces of things. See how these match? So they cancel. And when things cancel, they become 1. All right? Now, all we have to do, I'm going to rewrite it so it doesn't look so messy. I have 3 plus 5i in the numerator and 1 plus 3i in the denominator. And I'm going to multiply top and bottom by the conjugate of the denominator. So I'm going to get 3 times 1 is 3 minus 9i plus 5i minus 15 I squared. And then I'm going to do my quick conjugate multiplication, and I'm going to get 1 plus 9 in the denominator. Now I'm going to simplify. I'm going to move back over, and I get 3 minus 4i, and then minus 15 times negative 1 over 10. And then I get 3 plus 15, so that's 18 minus 4i over 10. Now let's factor out a 2 in the numerator, and I get 2 times 9 minus 2i over 10. And so I'm going to cancel, and I get 9 minus 2i over 5. And here's your final answer. Okay? All right, we're going to work on these problems tomorrow. So I'll see you then. Thanks for listening.